We use electricity to power every aspect of our lives. Simple stuff like making a cup of tea or powering our tablets and phones. We are on a journey to find out where some of this electricity comes from. We're inside a nuclear reactor, and if you look below you, you'll see we're travelling downwards, towards the reactor core. This system has just been refuelled. It is powered by fuel rods that contain uranium, which is a natural element that is mined from deep in the ground. We keep it here, inside these metal rods. Let's take a look inside. The system is about to be switched back on. To see how uranium makes energy, we'll need to get smaller though. Now we're shrinking to an atomic level. Here, right in front of you, there's rows and rows of uranium pellets. In total, there are over 2 million fuel pellets in the whole reactor. And it's inside these pellets, each only a centimetre tall, that nuclear fission happens. Let's get even closer. At this scale, we can see actual atoms and neutrons. Neutrons are the particles that help us unlock all that energy from the nucleus. But they move fast, so first we need to slow one down. And to do that, we simply use water. Let's follow this one and see where it leads us. Pay close attention. Firing this neutron into the nucleus of the atom causes the nucleus to split in two. This is the fission we mentioned earlier. And as the nucleus splits, it releases its own neutrons. Some of these newly released neutrons, slowed by the water, hit other atoms, causing more fission. And so the chain reaction begins. In our reactor, there are an incredible 5 million fissions per pellet per second. Look around you, and you'll see them happening everywhere. Each time a uranium nucleus splits, it releases its awesome energy. This energy heats the fuel pellets, and in turn the water in the reactor, to more than 300 degrees Celsius. The powerful chain reaction has heated the water in the reactor core, and this heated high-pressure water now travels through pipes out of the reactor vessel at 35 miles per hour. It all sounds very dramatic, but understanding the physics means we know how to regulate the chain reaction. In the space beyond the pipe, the heat from that water turns more water into steam. This steam is what drives the turbines. All of that power just to make a turbine spin. It's really quite a simple system. These steam-driven turbines generate more than 1,000 megawatts of electricity. That's roughly enough to power all of the houses in Greater Manchester. All of the steam leaving the turbine is condensed back into water and pumped back round to the steam generators to be turned back into steam again. So, here we are, back in the main reactor where we started. You see, the simplicity of this system makes nuclear power incredibly effective. As you've seen, with nuclear, a little goes a very long way. Something to think about when you next make a cup of tea or charge your tablet. If you want to find out more, visit us at edfenergy.com/virtual tours.